Alright, let's take a look at the 7th question on the practice exam. So normally my tests are 6 questions long, but all these questions are really short. So all the videos have been 5 minutes long, so I think that you're going to have time to do 7 questions. And this is some really important stuff to know, how to solve trigonometric equations. You're going to have to do that all the time in calculus. And okay, so we haven't done this in class yet, but I'm just going to start with A. I'm going to find all solutions to this equation. And the strategy here is to isolate the trig function. Okay, so isolate the trig. So I want to get cosine by itself. So how can I do that? Well, I can just solve for cosine. If you solve for cosine, you see that cosine x is equal to, first this 1 goes over and becomes positive 1, and then you divide through by the square root of 2. You get 1 over the square root of 2, and this may be more familiar to you as the square root of 2 over 2. Okay, so now we have to ask ourselves, what value of x makes cosine equal to the square root of 2 over 2? And if you remember your unit circle, you will remember that the angle that does that is pi over 4. Okay, so it's pi over 4 that makes cosine equal to square root of 2 over 2. And okay, so that is one solution. Okay, it's the solution that occurs in the positive quadrant. But this says find all solutions. So by all solutions they mean all the solutions that occur in the whole set of real numbers. Okay, and so that's not as scary as it sounds, because cosine is a periodic function. So since pi over 4 solves this, okay, so pi over 4 solves this equation, cosine x equals square root of 2 over 2. Not only does that solve the equation, but pi over 4 plus n times 2 pi does for any integer n. So an integer is a positive or negative whole number. Okay, and I'm going to draw a little picture here of what's going on. So, you know, cosine goes up and down and up and down and up and down and up and down. And what we found is that when you put in pi over 4, let's say, here's pi over 4, then a certain value comes out, which is, you know, 1/2, or sorry, it's not 1/2, it's the square root of 2 over 2. Okay, so that makes pi over 4 as a solution. But look, there are lots of other solutions too. Lots of other solutions. Okay, and they go on infinitely like this. So when you take this point and you add pi over 2 to it, you get here. Okay, so here, you know, this you add, I don't know what I said last time, but what you should add is 2 pi. Okay, and then you add 2 pi again, and you get here, and then you add 2 pi again, and you get here. Okay, and this goes on forever, and it also goes on in the other direction. Right, so this is what happens if you take away 2 pi. You get another solution. Okay. Alright, so notice that we're missing some. So we haven't written down what this one is. So there's another family here, another family of solutions, and these are also separated by 2 pi. So what are those? So look back here at the unit circle. Those are coming from this. Right? Cosine gives you the x-coordinate, which is the square root of 2 over 2 right there. So one angle that does that is pi over 4, but there's this other angle minus pi over 4 that also does it. So these red things here are coming from that. Alright, and so here's one family of solutions, and there's another family of solutions which comes from making this negative. So I guess if I were lazy, I could write just plus or minus here in front of pi over 4. But let me go ahead and write out minus pi over 4 plus n over 2 pi. Or sorry, n times 2 pi. And so this is still for any integer n. Okay, so for any whole number n. And so that's the whole answer to this question. All right. And let's go through here and look at the second one. So the second question is about cotangent. And it's saying, when is cotangent plus 1 equal to 0? So let me rewrite that here. We want to solve cotangent x plus 1 equals 0. So the same thing as cotangent x equals minus 1. Alright. And so remember what cotangent of x is. Cotangent of x is cosine x, whatever that is, it is cosine of x over sine x. Okay, so, you should know that sine x equals plus or minus cosine x at these points, right? At pi over 4, and then pi over 4 plus pi over 2, this thing. Right, these are the places where you have cotangent being plus or minus 1. And so look what happens here. Here at this point, pi over 4, cotangent is just going to be 1, because this is the point square root of 2 over 2, comma square root of 2 over 2. It's going to be these two where the signs disagree, right? Because this one is going to be minus square root of, it's plus still. So square root of 2 over 2 and minus square root of 2 over 2. And this one is going to also be a sign mismatch. It's going to be minus square root of 2 over 2 and square root of 2 over 2. Okay, so these red points are the places where cotangent of x is equal to minus 1. So those are going to be the solution. Alright? Okay. So I could write down two families of solutions involving 2 pi like I did for cosine. It's actually easier than that because cotangent has a whole period between pi over 2 and minus pi over 2. So unlike sine and cosine, cotangent and tangent have period pi. So what happens between pi over 2 and negative pi over 2 says everything about them. And so what I could do is just record this solution and then say plus some integer times pi. So that's what I'm going to do. So what is this angle? This angle that goes down kind of to negative 45 degrees. I'm going to call it minus pi over 4. And so the family of solutions for this is minus pi over 4 plus n times pi, because it's period pi. Okay, and this now n is any integer. And if you wanted to draw a picture of what's going on here, not going to be a straight line. Okay, so cotangent goes kind of like this. So here, this dashed line, this first vertical asymptote, happens at pi. This is 0. And so what we found is that at minus pi over 4, which is like right here, we get a solution. So I need another one over here. So it goes like this. Alright, so, stupid thing. The one time I draw a good curve. And so what happens is what am I even doing? I don't know why I called this 0. I meant this to be minus pi over 4. So here at minus pi over 4, we get a solution because minus 1 comes out. So see how that's just describing this? Alright, and then it's periodic with period pi. So the other solutions are just this one plus a pi gives you another one here. Then plus a pi gives you another one here. And that's where they all come from. You can see that this is going to generate all of them. If you were to look at where this line at negative 1 intersects all the cotangents, it's going to be exactly at all these green dots. So this is the solution. This is the solution. And that's the end of the problem.